Hello students, in our last session, we have gone through how do we name the coordination complex compound, that is nomenclature we have gone through. The second one, oxidation number, how do we calculate the oxidation number of coordination complex compound. That is also we have gone through. In this session, we are going to give the name for anionic complexes, cationic complexes and neutral complexes. Very easily we can identify, as we look at the compound only, we can identify whether it is a anionic complexes or cationic complexes or neutral complexes. And one more thing here, how many ions present in the coordination complex compound in aqueous medium, that is also let us go and identify. Come on, let us go and learn the first one, K2NiF6. As you look at this compound only, you will come to know which is counter ion, which is coordination sphere, ligand, coordination number, and central metal ion. And you can calculate the oxidation number also very easily. Come on, let us go and give the name for it. This is potassium, potassium hexafluorido, hexafluorido nickelate, and this is oxidation number 4 in Roman numeral. Okay, the second one, K2COCl 4 times. Okay, that means this is potassium, potassium tetrachlorido, tetrachlorido cobaltate, cobaltate. And you know how to calculate this oxidation number? This is oxidation number 2. You know what is the speciality of anionic complexes? The central metal ion, as you are mentioning the central metal ion, the suffix will be ATE. Okay, now that is the speciality of the anionic complexes. But whereas cationic complexes and neutral complexes, the same central metal ion, the same name will be like Latin name, it will be remaining the same. Okay, that is only meant for cationic complexes and neutral complexes. Why I'm comparing, you will remember, that is the reason. Okay, now this next one, KCO2O4 twice, NH3 twice. Okay, now in this, what is the name? Potassium, potassium. According to this, there is two ligands are there, so we have to give the priority for alphabetical order to give the name. So that means diamine, dioxalato, cobaltate. According to that, you have to give that what it is, oxidation number also. Okay, now this is what it is, diamine, diamine, dioxalato. I just mentioned here because it has to be in one word only. Please remember this ligands, it has to be in one word, whichever is present in the coordination sphere, that bracket, everything it has to be in one word only. Okay, so you should write it in that way because there is no space. So I am bringing here dioxalato, oxalato, cobaltate, cobaltate, and oxidation number what it is here, 0. This is neutral ligand 0, and this is -2, and this is +1, so naturally it is +3 oxidation. So whenever you are writing that oxidation number, it has to be in Roman numeral. Okay, I hope you got a clear idea. Okay, the next one, K2NiCN6. Okay, K2, this is potassium, potassium hexacyanido, hexacyanido nickelate, nickelate. And you know this is -1, so that means -6. This is +2, so that means automatically 4 oxidation number. Okay, now next one, K3CrF6. That means here potassium, potassium hexafluorido, hexafluorido chromate, chromate. Okay, now this is what it is. Here -6, here +3. So naturally +3 oxidation state. Okay, now next one. Potassium hexacyanidonicolate. Potassium hexacyanido. Cyanido. Is it visible? Yes. Hexacyanidonicolate. Nicolate. Nicolate. Here -6. Here -1, so -6. Here +3. So here 3. Oxidation state 3. Hope you understand very clearly all these naming compounds. So these are all anionic complexes. In our last video also, some of the anionic complexes name we have mentioned very clearly. Okay, now we are going to see the cationic complexes and neutral complexes. What are the difference between anionic complexes and cationic complexes? Let us go and identify. Generally here, anionic complexes, cationic complexes. When the ions are dissociate positively charged, that is called anionic complexes. When the ions are dissociate positively charged, that is anionic complexes. Whereas ions are dissociate negatively charged, that is cationic complexes. When they dissolved in aqueous medium. Please note that when they dissolve in aqueous medium. Come on, let us go and identify the name of this cationic complexes. Okay, now cationic complexes and neutral complexes, that central metal ion will be same as it is. There is no suffix ate, right? Now come on, let us go and identify the name. Here, hexaamine platinum 4 chloride. See, everything should be small letter only. There is no caps, and inside the coordination sphere it has to be in one word only. Hope you're clear with that. So how to write that anionic complexes, how to write the cationic complexes, I hope you got a clear idea. Okay, come on, let us go some more examples. Here how do we identify tetramine diaqua copper 2 sulfate, right? Come on, tetramine tetramine diaqua aqua copper copper 2 sulfate. Hope you're clear with this, how to write the name. Next one, here CrCl2H2O 4 times. So tetra aqua. This is also we are following what it is, alphabetical order. So tetra, penta, di, mono, that and all we are not going to give that alphabetical order. Only we are giving that alphabetical order priority for the ligands only, right? Okay, now tetra aqua dichlorido, chlorido, chromium, chromium. This is 1 and this is 2. So 3 nitrate. Nitrate. See, there is no space. That's what I just bring it here. Everything it has to be in one word only. Hope you're clear. How do we write it, that cationic complexes, and how do we write it anionic complexes? What do you mean by anionic complexes and cationic complexes? How do we differentiate anionic complexes and cationic complexes? Okay, now some more names. Let us go and identify the cationic complexes name. Okay. Now let us write this dichlorido, chlorido, bis, ethane, 1,2, diamine, diamine, chromium, chromium 3 nitrate. Okay, the next one. Here, tris ethane 1,2 diamine manganese 3 chloride. Tris. 3 is there, no tris. Ethane, ethane 1, 2 diamine, diamine manganese, manganese, manganese 3 chloride. Okay, now next one. Here, tetramine, 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 according to that alphabetical order only, right? So tetramine, chlorido, chlorido, nitrate, nitrito, nitrito. Nitrito means NO3. Nitrito means NO2. Please note that. Okay. And next one, platinum, platinum, and here 2 and here 1. So 4 sulfate. I hope you got a clear idea about oxidation number. How do we identify? The next one. Here, hexa aqua manganese 2 chloride. Hexa aqua, hexa aqua manganese, manganese 2 chloride. Hope you're clear with this. Okay, the next one. Here, hexa aqua nickel 2 chloride. Hexa aqua nickel, nickel 2 chloride. The next one. Here, amine, chlorido, nitrito, cobalt 3 chloride. Amine, amine, chlorido, chlorido, nitrito, nitrito, NO2 only, no. So nitrito, cobalt, cobalt 1, 2, 3, 3 chloride. Okay, hope you got a clear idea. Okay, let us go and identify some more examples of the cationic complexes and neutral complexes. Now the next one, tetramine, chlorido, nitrito, cobalt 3 chloride, right? Tetramine, 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 chlorido, chlorido, everything small letter only, and there is no gap in between. Okay, chlorido, nitrito, nitrito, cobalt, cobalt 3, 1, 2, 3, 3 chloride, chloride, right? Okay, the next one. Here, hexamine, nickel 2 chloride, hexamine, hexamine, nickel, nickel 2 chloride. See, these are all NCRT exemplar questions. I just mentioned all these important questions. You can expect all that. Okay. Here, diamine, chlorido, methanamine, platinum 2 chloride. Diamine, chlorido, tetrachloridomethanamine. Methanamine. Methanamine. Okay. CH3NH2. Methanamine. Platinum. Platinum. 1, 2. 2 chloride. Chloride. Hope you got a clear idea. Okay, the next one. Hexa aqua manganese 2. Hexa aqua manganese 2. Right? Now next one. Here. Tris ethane 1,2 diamine cobalt 3. Tris ethane 1,2 diamine cobalt 3. Right? Next one. Titanium, that is hexa aqua titanium 3. Hexa aqua titanium 3. Then next one. Here. Tetrachlorido nickel 2. Tetrachlorido nickel 2. Alright? Hope you're clear with that. Okay, now we are going to see the neutral complex ions. Now let us watch neutral complexes. Okay, the name of the neutral complex is tetracarbonyl nickel. See, neutral complexes and cationic complexes, the name of that central metal ion will be same. There is no suffix ate. Please note down. So here what it is? Tetracarbonyl nickel. It is actually oxidation number 0. Here pentacarbonyl iron. This also oxidation number 0. Here diamine dichlorido nickel. But oxidation number what it is? 2. Please note down. Okay, now the next one. Here hexacarbonyl chromium. Hexacarbonyl chromium. Here oxidation number 0. Hope you're clear with the cationic complexes, anionic complexes and the neutral complexes. Now we are going to see cation and anion combined together. Such kind of formulas let us go and identify, and name of the complexes ion also. Now let us go and identify some of these kind of complexes, ion, cation and anion together. So first part, 2 parts are there. First part we can take it as a cation and second part we can take it as an anion. So in that way, the same rules we are following. Tetramine platinum 2, tetrachlorido platinum 2. Tetramine platinum 2, tetrachlorido platinate 2. Right? The next one, tetramine dichlorido platinum 4, tetrachlorido platinum 2. Okay, I'll change the pen. Tetramine tetramine, dichlorido, platinum, platinum 4, tetrachlorido, platinate, 2. You got a clear idea? Okay, the last one. Here, the name which is tetramine, dichlorido, cobalt, 3, and hexacyanido, chromate, 3. See, for anionic complexes, suffix ate. Okay, now let us go and calculate the oxidation number of these anyone. Okay, now the last one only, let us go and take it. See, generally, first part it is a cation, the second part which is an anion. Okay, now this we can take it as a cation, and the second one which is an take it as an anion. Okay, so we can take it positive and negative. So in this, here it has mentioned CO, Cl2, NH3 4 times, the whole number thrice. Okay, now in this, here what it is? Central metal ion. So this is combined together only, no. So we can take it 3x because 3 it is there combined together. So 3x plus, here 2 it is there, here 3. So 3 2s are 6. And anion Cl how many? -1 plus. Of course, this is 0. No need to consider. So this is 0. Next one plus. Here, this is we can take it as a X. Chromium ion we can take it as a X plus 6 into -1. Right? Is equal to 0. Okay, now 3x minus 6 here plus x here minus 6 is equal to 0. So that means here let us come to this point. X plus 3x is equal to minus minus. So 12. So that means here 4x equal to 12. So x equal to 12 by 4. 3. So that is what it has mentioned. 3. Okay, 3 and 3. One more. This also let us go and identify. Here common 3 only, no? So here let us go and identify. Plus 3 minus 2 plus 0, right? Here plus 3 minus 2 0. In this whole thrice it has mentioned. The same way here 3. This is 3 common, right? 3 minus 6. Okay, now let us go. This is plus 3 minus 2 here plus 1 and thrice. Here 3 minus 6 here minus 3. So here plus 3 and here minus 3. So oxidation state, that is cation part it is plus 3, anion part minus 3. That is what it has mentioned, 3 and 3. Hope you are clear. How do we identify the oxidation number of this complex compound? I think you're very clear about the nomenclature of anionic complexes, cationic complexes, neutral complexes, and such kind of these complexes also. Okay, in our next session, we are going to learn isomerism of coordination compounds and VBT theory, Werner's theory, and some more interesting and important questions. Thanks for watching. Please subscribe this channel so that you will get all the notification.